All right, we are going to begin on page 622 in your books, section 11.5, geometric probability. And before we get into geometric probability, we want to review a little bit what probability is. So if you'll recall, probability is what you want over everything that is possible. And this is often used with, marbles in a bag or something. And so if you have a bag of marbles and it has 3 blue ones and 2 green ones and say 4 yellow. If you wanted the probability of blue, you would say, well, that is 3, because that's how many blue I have, over how many I have altogether, which if you add it all up would be 9. So 1/3 in fraction form. And if you want that in percentage, you would divide that out. You would get, of course, 0.3 repeating. And so as a percentage, it would be approximately 33% for the probability. So just refresher, that is what probability is. And so if we talk about it in terms of geometric probability, then we are looking at exactly the same thing, what we want over what is completely possible. And so they gave us this key concept here. If a point in region A is chosen at random, what's the probability of B, meaning that the point is in the region B? So think of it this way. If you were to throw a dart at this area right here, this whole thing, what's the chance that your dart will hit that circle? Well, you would say the area of the circle here, area of region B, divided by the total possible. Well, the total possible is the entire region of that rectangle, area of the rectangle. And so that's geometric probability. So let's look at the first example. The first example they gave us is a grid test. The square game board has black and white stripes of equal width as shown. What is the chance that a dart thrown at the board will land on the white stripe? Well, you obviously have 2 different types of stripes, black and white, black and white, black and white stripes here. And so they've broken it up into squares. So if we want it to land on one of the white stripes here, we would add up all of those squares. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 white blocks there. And so that would be what we are trying to get it to land on, one of those 15. And then the total number that we have, well, that's just the area of this. So you can just multiply base times height. It's a square here, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have a 6 by 6 square here. So that means the entire region is going to be 36. And so we would say 15 over 36. Of course, you always want to reduce it. You know that 3 goes into both of those. So you would say it's 5 out of 12, 5/12. And if they wanted that into percentage, you would take 5 and divide it by 12, and you would get 0.416 repeating. And so if rounded to the nearest percentage, you would say 42% there. And so that would be your probability. So now we're going to try one. So page 625, number 8, I want you to try the probability of landing on the blue portion of this particular picture. All right, so you should have gotten 50% or 0.5 when you did this, or if you did 1 out of 2. So what we're looking for is the shaded region. So if you count those up, you should have gotten 50 blue squares. So that would be your numerator. And the total area is 100. And so 50 over 100 is the 1/2, or as percentage, 50%. The next type of probability introduces a new formula of the area of a sector. So we talked about the length of an arc when we did it in circles with chapter 10, but this is actually the area. So if you think of a piece of pie, then what the area of that pie would be. And it's similar to doing the length of an arc with circumference. So if you recall the length of an arc, we did whatever the degree was divided by 360. That's the percentage of the circle you have, and then you multiply it by the circumference. Well, now we're finding area, so you do the same thing, but you do it with the area formula. So you have the measure of the angle divided by 360 times your circle area, pi r squared. And so that is what a sector is. The sector is that little piece of the pie, and you're just finding that area. So if you look at the next example, they have given us this circle, this kind of pie chart here, and they want us to find the area of the blue sector. So we're going to use this formula that we have been given, the angle measure over 360 times pi r squared. And so the angle measure of the blue sector right here is 46 degrees. So we would take 46 over 360, and we would multiply that by pi, and my r here has not been given. They gave me the diameter. So remember, you take the diameter divided by 2 to find your radius. So your radius here is 6, and then we're going to square it, pi r squared. And so when you simplify that, you get, in your calculators, if you do 46 divided by 360 times 36, you are going to get 4.6 times pi. Now they left pi in it, so it just depends on whether they ask you to leave it in terms of pi or whether they want you to actually carry it out to a decimal place. And so just pay attention to your instructions for that. Now the next question says, find the probability that a point chosen at random falls in the blue region. Well, we already know the total area of the blue region. We just found it to be 4.6 pi. That's what we want. We want it to fall into the blue region. So this is what we want. And remember, probability is what we want over the total. Well, the total is the total area of that circle. The total area of that circle is going to be just simply pi r squared. And so we're going to take our pi r squared and calculate the area there. Now, just like any other fraction, your pi's are in the numerator and in the denominator. You can reduce it by just canceling those out. So you get 4.6 divided by 36, which actually gives you 0.13 when rounded. And so that is rounded. And if you want percentage, that would be 13%. And so area of a sector, that is your degree over 360. And then put that over the whole circle if you want the probability of hitting that particular sector. What you will notice is, if you were to write this all out by just doing the probability, so if we go and just do this probability, it would be the area of the sector, 46 over 360 pi r squared, over the area of the circle, pi r squared. And so had they not asked for the area of the sector, then you could have gone straight to this point in finding the probability. And the pi r squareds will cancel, and it ends up being 46, the degree measure, over the total thing, 360, which will also give you 0.13 when rounded. So You do have to know how to find the area of the sector because I will ask specifically for just the area of a sector. But if they want the probability of a sector area, you can go straight to the degree of the sector divided by the total degree of the circle. So I'd like you to try one of these. All right, let's look at this together. So they wanted the area of the blue region, and then they wanted the probability of the point chosen at random. And so you should have gotten 17.5 as the area of the blue region. Just to recap that, you would have said 80 degrees over 360 times pi, the radius is 5, squared. And that's where you would have gotten the 17.5. For the probability, remember the probability ends up being just the degree of the sector over the 360, which would give you 0.22 or 22%. Homework, page 625 through 626, 7, 10, and 16. You also have a test on Friday covering the entire chapter 11.